The brake system plays an important role in decelerating, stopping, and parking the automobile. It consists of various components such as the brake pedal, brake booster, master cylinder, proportioning valve, disc brake, drum brake, and the parking brake lever and cable. Brake system maintenance requires utmost attention and accuracy. Oil or grease left on the lining or pad during maintenance causes brakes to pull to one side. Assembling a small part in the opposite direction causes brake fluid leak. Such carelessness may harm the customer or pedestrians. This video will provide information on the outline and operation of the brake system and troubleshooting for problems. To begin with, let's see the components of the foot brake and the operation. The force applied on the brake pedal is converted to a larger force according to the principle of the lever. There is a relationship between force F2 applied to the push rod of the master cylinder and force F1 applied to the brake pedal as shown here. When assuming that distance A is 5 times that of distance B, then force F2 will be 5 times the force of F1. The brake booster increases this force utilizing the atmospheric pressure difference. The need for brake boosters has increased along with the wider use of disc brakes without the self-servo effect. The drum brakes use friction generated by rubbing the drums against the lining to stop the vehicle. Opposite forces are applied to the front and rear shoe. The trailing shoe tries to push against the force, while the leading shoe is pulled into the revolution and produces a larger brake force. The increased braking force is called the self-servo effect. The disc brakes, which press the rotor disc with pads from both sides, do not have this self-servo effect. So a larger power needs to be produced by utilizing the brake booster. We'd like to learn more about the brake booster operating principle. A vacuum is created inside the brake booster by starting the engine. When the brakes are not applied, the pressure of the constant pressure chamber and variable pressure chamber are equivalent. When the brake pedals are depressed, the air valve makes contact with the control valve, making the constant pressure chamber and variable pressure chamber into 2 independent chambers. When the pedal is depressed further, the air valve moves away from the control valve, allowing air to enter the variable pressure chamber. This difference in pressure is used to push the push rod. When holding the brake, the difference in pressure causes the piston to move to the left. This allows the control valve and the air valve to make contact, preventing further air from coming in. When the brake pedal is depressed fully, The air valve moves away from the control valve again, allowing air to fill the variable pressure chamber. Therefore, even if the pedal is depressed further, the force generated by the difference in pressure will not increase anymore. Only the force pushing the booster pushrod will vary. The Tandem type brake booster is a compact and extremely powerful unit having 2 vacuum chambers. The force enlarged by the pedal's principle of the lever and the difference in pressure of the brake booster is converted to hydraulic pressure in the master cylinder and is transmitted to individual wheels. The substance transmitting the pressure is the brake fluid. If bubbles are generated in this fluid, the pressure will not be transmitted accurately, causing serious conditions such as decreasing the brake efficiency. Vapor lock has occurred. This is a condition where heat, generated by excessive use of the brake fluid, has caused the fluid to exceed its boiling point. It has been found that brake fluid used for a long time tends to absorb moisture and could cause the boiling point to drop. When brake fluid is leaking, would it seriously affect the braking force? The brake system is designed to have a divided hydraulic system to cope with situations like this. Even if one circuit fails, the other is still operative. FR and FF vehicles have different piping. The Tandem master cylinder operates this divided hydraulic system. We will take an FR vehicle as an example to explain the operating principle of the Tandem master cylinder. The Tandem master cylinder has a divided cylinder chamber. When brakes are not applied, passages exist between the respective cylinder and the reservoir tank. When the brake pedal is depressed, number 1 piston moves to the left, and the piston cup seals the passage between the cylinder and reservoir tank. At the same time, hydraulic pressure is generated, moving number 2 piston to the left, thus sealing the passage between the cylinder and the reservoir tank, and hydraulic pressure is transmitted from respective cylinders. Now assume that a fluid leak occurs in the rear side of an FR vehicle. Under this circumstance, number 1 piston does not create hydraulic pressure. Nevertheless, the number 1 piston moves to the left, makes contact with number 2 piston and pushes it directly. In this way, hydraulic pressure is created at number 2 piston and the brake force is applied to the front brakes. In the case of a leak in the front side, number 2 piston does not create hydraulic pressure, so it advances until it makes contact with the cylinder wall. When number 1 piston is pushed further under this condition, hydraulic pressure is created in the rear side. When braking, a larger load is generated at the front than at the rear of the vehicle. Therefore, if the vehicle tries to brake the front and rear wheels with equal force, the rear wheels, which are subjected to a smaller load, will lock up early, and the vehicle will become unstable. To prevent this, the brake force applied to the rear wheels must be adjusted. The P-valve is designed to automatically reduce the hydraulic pressure applied to the rear wheel cylinder from the master cylinder in proportion to the pedal force applied to the brakes. Inside, the piston is moved constantly due to the difference in the surface areas of the piston chambers. The dual P-valve would have a pair of P-valves operating side by side. This is usually used in diagonal brake piping of FF vehicles. In the case of hydraulic pressure failure in the front, the rear braking force adjusted by the P-valve would be insufficient. The P and B valve is designed to deactivate the P-valve under such circumstances. If a fluid leak occurs in the front brake circuit, the hydraulic pressure from the master cylinder cannot be transmitted. The force pushing the number 2 piston is lost. As the force pushing number 2 piston from the left side is stronger, it will always be pushed to the right. Accordingly, the hydraulic pressure can transmit the strong braking force directly to the rear wheel cylinder without the operation of the P valve. Wouldn't the normal P valve be inconvenient when having a payload on the rear, such as in commercial vehicles? That's right. When the vehicle is loaded, a large load acts on the rear wheels. This necessitates increasing the hydraulic pressure to the rear wheel cylinder. The LSPV is designed to have such regulating functions. Here, the piston of the LSPV is being moved upward by the load-sensing spring. When the load is small, the spring does not make contact with the piston. On the other hand, when the load is large, the spring moves the piston upward. The boosted and adjusted brake force is eventually transmitted to the drum and disc brakes. Motion energy is converted to thermal energy and the vehicle stops. Types of drum brakes depend on shoe installation or number of cylinders. For example, the leading trailing shoe type. 2 leading shoe type. And duo servo shoe type. The hydraulic pressure transmitted to the wheel cylinder forces the shoes apart. The lining installed outside the shoe rubs against the drum, revolving with the wheel and produces brake force.
So the clearance between the lining and the drum must be kept constant?
That's right. The clearance must be adjusted periodically. However, some systems do this automatically. When the parking brake is applied, the lever is pulled to the left. If there is excessive brake shoe clearance, the adjuster lever would go over the adjuster screw notch. When the parking brake is released, the adjuster screw rotates and adjusts the brake shoe clearance. In the disc brakes, the rotor disc rotating with the wheels is pressed from both sides by disc pads operated by hydraulic pressure and stops the vehicle using friction. The ABS is a system which controls hydraulic pressure precisely and ensures directional stability even at sudden braking.
Does the disc brake have an automatic clearance adjuster for the clearance between the rotor and the disc?
Yes, it does. In the disc brake, the piston seal is deformed as the piston moves. When the brake pedal is released, the piston seal returns to its original shape, therefore pulling the piston back. In the case of pad wear, the piston movement may exceed the deformation amount of the piston seal. In that case, the piston slides and adjusts to a new position. In this way, the clearance between the disc and the pad is always maintained at specification. The parking brake is used to park the vehicle after stopping using foot brakes. Most parking levers have wires or rods which are connected to the brakes of the rear wheel or propeller shaft and are operated by pulling the lever. In the drum type, the brake shoe is forced apart by pulling the cable, and the drum is locked. The disc type in compact vehicles has a crank pin or a spindle in the caliper, and the piston is moved to push the pads against the disc. These are some examples of the problems observed in the brake system. Here is a lineup of some of the typical problems and troubleshooting for them. Inappropriate brake pedal height or insufficient free play could cause brake drag. Check the height of the pedal. Remove the floor carpet under the pedal and measure the distance between the asphalt sheet and the surface of the pedal. In this case, the pedal must be adjusted. Remove the wire connector from the stoplight switch. Loosen the lock nut of the stoplight switch and turn the switch itself 2 or 3 times to loosen it. Loosen the push rod nut and adjust the pedal height by turning the push rod. Tighten the stoplight switch until the pedal stopper makes contact with the cushion. Then tighten the lock nut. Connect the wire connector to the stoplight switch. Next, check the pedal free play amount. If the engine is running, stop it and depress the pedal several times until the pedal reserve distance, when depressed, becomes constant. This is to reduce the vacuum inside the brake booster. Measure the pedal stroke by depressing the pedal by hand until resistance is felt. Adjust the free play if necessary. Loosen the lock nut of the master cylinder push rod and adjust it by turning it. Tighten the lock nut and measure the free play again. Finally, check the pedal height and the stoplight operation. If there is a problem with the brake booster, it could cause unexpectedly strong or inefficient braking. There are several, although not perfect, ways to inspect the brake booster. First, check air tightness. Stop the